Good morning, good afternoon, and good evening, everyone, depending upon where you have joined from. And welcome to another webinar from Data Platform Geeks. Today, our session is on Azure Machine Learning for MLOps, and our speaker is Mercy Ranjit, who is a solution architect from Microsoft. She's also our speaker from our recently concluded Data Platform Summit. My name is Satya Ramesh, and I will be the host for your next 1 hour. And Aarthi Nambiar is helping me with moderation. Before we move forward, just a quick word about who we are and what we do. And under Indomina Systems, we have a couple of brands under SQLMaestros. We do a lot of advanced trainings on SQL Server, data and analytics space, and artificial intelligence space. And we also have a couple of self-paced learning solutions like learning kits and hands-on labs. And recently, SQLMaestros is also coming up with video courses. I'll talk about all SQLMaestros a bit later. And SQLMaestros also have famous health check service as well. And Peopleware India, which is Indomina Systems corporate training unit, and a famous ERP product also called Expand SM ERP. And today's our concentration is on Indomina's community wing. SQL Server Geeks and Data Platform Geeks communities were founded by Amit Bansal in the year of 2010, under which we do a lot of free in-person events and webinars. Once in a year, we do annual summit, which is called as Data Platform Summit. Here is a picture of recently concluded Data Platform Summit, which has happened in Radisson Blu in the month of August, and where people from 300 plus companies attended this particular summit. There are close to 1,000 people each day. It is a 3-day summit. Speakers generally travel from 20 plus countries, and they'll deliver 100 plus sessions in the span of 3 days. So this is a quick introduction about Data Platform Summit. If you want to learn more about Data Platform Summit, you can visit dps10.com, or else you can simply drop an email to contact@dps10.com. Here is a quick picture of Edomner and DPG's teams on the stage of Data Platform Summit 2019. Here is the picture of DPG core team, Amit Bansal, who is founder and president, and Manohar Punna, who is a vice president. And you can also see all other regional mentors from various cities across the world. Here are the Edomner teams that help us organize these kind of free events. And a special thanks to Microsoft in supporting our community efforts. And you are a member of Data Platform Geeks. If you have directly joined with joining link, you can become a member. Once you are a member, you will be able to get updates about our upcoming free events and webinars as well. And you can able to access our free videos, labs, magazines, and other host of learning resources also. And please whitelist Data Platform Geeks domain so that you won't miss our updates. Especially events at dataplatformgeeksdomain.com. Events at dataplatformgeeks.com. You can add to your address book so that you won't miss out any of the important communications from us. Here are the quick joining links, Facebook group, LinkedIn group, and Telegram group. Beyond this webinar, if you have any questions, you can always post your questions there in Facebook group, LinkedIn group, and Telegram group as well. And we do record all these webinars, and we'll upload all the webinars under youtube.com/SQL Server Geeks. And we also have another channel called youtube.com/SQLMaestros, where we do upload a lot of SQL Server related, performance tuning related videos. And again, we have a group in Telegram. Here is the link again. And without any further delay, I'm just handing it over to Mercy Ranjit. Mercy, over to you.
Yeah, thanks. Hello, everyone. Thanks for joining. Let me quickly share my screen because I have a lot of demos to go through. Let me know once you are able to see my screen. So let's get started. So I am Mercy. I work for Microsoft as a cloud solution architect, and I help customers develop AI solutions on Azure. And today we are going to see how we do MLOps on Azure. So this is what I have on the agenda. So we will have a quick Azure machine learning platform overview, and we will look at the different data science assets which are involved as we develop and release models with Azure machine learning platform. And then we will emulate as a data scientist, and we will go through a complete model development pipeline with Azure. And also we will, once the model is developed and registered, we will also go through a release pipeline, and we will see how the build and the release pipeline is integrated with Azure DevOps to give a very seamless experience of developing, building, and releasing your machine learning pipelines, as well as retraining whenever your data changes, or whenever you optimize your code of your machine learning models. And finally, we will also look at data drift, how we can detect data drift once your model is deployed, and how we can automatically trigger model retraining whenever a data drift is detected. And also we will look at the final MLOps architecture with all these integrations in place. Now a quick overview on the Azure Machine Learning Service. It's an end-to-end data science platform on Azure, which helps data scientists and machine learning engineers to help develop and deploy models at scale in production. And it offers a variety of authoring experience, right from if you are a coder and you prefer coding, then it offers you an SDK-based approach where you develop either in your favorite IDEs or notebooks. Also, it offers you, if you're a more UI-based person, it also offers you a drag and drop kind of an interface, which allows you to develop models quickly. And recently, Azure Automated Machine Learning is also with Azure, which basically helps you completely automate this data science model development pipeline of pre-processing your data for your models, feature engineering, model selection when you try with different models, and hyperparameter tuning. So the entire pipeline is being automated, and that's being also offered as part of the Azure Machine Learning Service. And also the entire platform allows you to manage the different assets which are involved as you develop your models, right from your data sets. So you can register data sets, you can version your data sets, you can profile and see the statistical characteristics of your data sets. You can monitor the data sets for any drift which is happening on your data. And also, if you are developing computer vision models, it also has a module which allows you to label the models for your classification and object detection. And a second part, coming to the second part, which is the model training and the management part, it allows you to experiment and track the different machine learning runs you do, which basically means that you will be able to track all the metrics and outputs which are being generated from your model experimentation runs. And also it helps you map these runs to the registered models which comes out of those runs, and also trace it back with the data set which you used to develop these models. And coming to the model serving part, it has options to deliver models either in a batch mode where you have a lot of data to score against, also against a real-time scoring method. So we have support both the methods of model serving at scale. Coming to the compute, it offers a variety of computes, both CPUs, individual CPU, GPU virtual machines, or be it a cluster, CPU cluster, or a GPU cluster, or it be a Databricks Spark cluster. So variety of computes can be attached to your machine learning experiments, and you can, and even a local compute can be used. And also it supports a variety of frameworks. Specific estimators has been built on top of popular frameworks like scikit-learn, PyTorch, TensorFlow, Keras, or you can also, if you're using a totally different framework, that is also possible, because you develop these images and you can specify the dependencies for your images from where your model is going to run, and it's going to get deployed. So there is a complete flexibility in terms of what machine learning frameworks you're going to use for your model development. And also the models, the developed models can be deployed either in a cloud-based environment or in your own edge devices, including hardware-accelerated environments like FPGAs. So with that, let's get into the topic of Azure DevOps and machine learning. So when we really develop a model, we see that it's rarely a one pipeline to manage. The reason being, we have different kind of activities involved in model development, right from a data engineer being involved, who integrates data from various sources, brings it into a single place, has your data curated, and then comes your data scientist role, where they take the data further, they pre-process it to do normalization, one-hot encoding, and then they go ahead with featureization, try different models, and then they evaluate those models against the validation data sets. They hyperparameter they do hyperparameter tuning, and then once they are satisfied, after multiple iterations, they register the models, have a model which is ready to be deployed, and they register that. And then comes the ML engineer role, who's mainly involved in taking that model which is found to be a good fit, package that models along with all the dependency which was used to create that model, create a runtime environment for the model in a scalable way, be it a batch scoring scenario or it is a real-time scenario, profile and see whether you are getting the required throughput for your predictions. Then comes the overall approval process of releasing your models, and then basically your model gets into production. And even then, after it gets into production, there is a process of validating your model continuously on the incoming data, whether it is still performing good. And then this whole pipeline is repeated. So where it's not just a single pipeline, but it's basically a combination of multiple roles and multiple pipelines which are involved in this whole data science development. Though there are companies which don't delineate these roles separately, but a single person does all these things. So in more complex environments, basically this forms different pipelines. So given that, let's get into the shoes of a data scientist, and we will see how he starts with a typical machine learning project, and see how Azure helps a data scientist to go through from the phase 0, which is the experimentation phase, to that final ML engineer phase of model deployment and maintenance. So for experimentation, typically when we are experimenting with the models, we have to track the data sets we are doing we are using for the experimentation. The different kinds of experiments we are performing, we might be doing experiments using different machine learning models. So we might have multiple runs which we need to track and understand. And we might be, for each of these runs may produce different metrics, different outputs. Each models might be associated with different hyperparameters and different dependencies. So all of these needs to be tracked, so that once, say, one data scientist leaves, it's not totally something which is maintained in his own local notebook, but it's basically in a more maintainable fashion. And when you look back, you have a more meaningful answers to give on how you went through this data science development pipeline. So given that, let's quickly, I'm just coming out of this PowerPoint presentation mode and getting into the demo, showing what is there in the machine learning workspace and how a data scientist starts with the model experimentation. So let's go to the Azure Machine Learning Workspace. So this is what you see in Azure Machine Learning Workspace. You have different authoring mechanisms, as I told. Right now for the demo, I'm going to use my local Anaconda itself, and from here I will be connecting to the Azure Machine Learning Workspace. As I said, you have different assets which is maintained, which is the data sets, which you version, profile, and you monitor. You have the different machine learning experiments you run, which are being tracked in the cloud. Once your experiments are through, you have a deployable pipelines, which may be a real-time pipeline, or it can be a batch pipeline which is deployed. And also you have all your models which you develop, registered and versioned and maintained. And then finally is your deployments, which can be a real-time endpoints or batch pipeline endpoints, which runs after your model is deployed. And in terms of the resources which are underlying the compute, you might have a single virtual machines, or you might have clusters which you attach, which can be a Spark cluster, CPU, GPU clusters, which you attach to the workspace, which to run your experiments, or it might even run on your local compute itself. And also you have different data stores which you can create, which basically has your data store, which has your source data. So your data store can be any of these different sources which is there in Azure. And also you might also be uploading from some website, or you might also be uploading data from your local data store as well. So data set is an abstraction on top of a data store, which helps you version your data sets. And also it helps you maintain a a single abstraction over all the underlying data sets. Your underlying data sets may be a SQL database, or it can be a file, or it can be from a data lake. So the data set basically helps you to maintain a single level of abstraction over the data set. And be it a Spark data frame or a Pandas data frame, your data set will help you treat them all in the same way. So that's about data set. And also you have a data labeling project, which allows you to label the data sets for your vision projects. So given that, let's quickly get into, we have seen what is there in the workspace, what kind of asserts are there. Let's quickly get into and see how we can start as a data scientist and keep track of your experiments and runs you make in Azure. So for this session, I'm going to go with a code-based approach, as we will be seeing the complete build pipeline at work. So let's assume that we are developing a regression model using the diabetes dataset, which is available with scikit-learn itself. So I will be using, since I said it, I'm using a code-based approach. The way I interact with Azure Machine Learning is using SDKs. So in my local Anaconda environment, I have installed the SDKs. So I've imported the SDK, and if you see, I am initializing my workspace, which is basically my subscription, the workspace name, and region where I'm going to maintain all these machine learning runs. So I'm creating an experiment, which basically, though I'm running it local, it gets logged into Azure. And also I'm attaching the compute resource. I might prefer to run it locally, or I can run it on any compute. So I'm going to run it on an Azure cluster, which is just a CPU cluster of 4 nodes. So I'm going to run this against that cluster, which I already have. So let me quickly show you that cluster which I have attached. So this is the compute. And there is a training cluster, so CPU cluster, which I have attached. And this cluster can be, I have 4 nodes currently idle. So I can use this cluster right from my notebook, and I can see what's happening as I run this experiment. So as a training data, as I said, I'm going to use the scikit-learn's data itself. So I'm loading the data. I have uploaded this data to the block storage, as you see already. So the data is there available with block storage, and I have also registered. So the data store is the block storage, and on top of that, I have created a file data set, because these are files for me, so that I can version these files, and how I can show you how you can version data sets and maintain the version of the data sets against the models. So there is a data set I have created already. I have registered this data set in Azure. I will show you that. And now I'm also getting that data set, an existing data set which has been registered, so which we will use against our experiment. Then this is a very simple training script, if you see, which has been written, which basically has it's just loading the features and the labels and from the data set. And the only difference I want you to notice is I'm getting a run, which is the machine learning run, which is the Azure machine learning run. And you see I'm logging some metrics which I generate. Since it's a regression model, I get a mean square error, and also the hyperparameter alpha, which is for the regression. And also you notice that, so I'm logging these parameters, and also you notice that I have a model which is generated, which is being saved into a folder called outputs. So outputs is a folder, the special folder, which basically automatically, when you write to this folder and you execute your experiment, the outputs are automatically streamed to the Azure storage, and it's maintained and versioned there. And also you also need dependencies to run your model, right? So basically, because I'm going to run on a different compute right now, I specify the Python dependencies I use for my model. And then I finally submit my training run. So if you see, I have created a simple estimator object. You have a specific estimator, special estimators for scikit-learn, Keras, TensorFlow, PyTorch, all. So you can use those estimators because it reduces a lot of, you need not, when you use specific estimators, you need not specify that you need to use scikit-learn package, because those packages are automatically included in the environment. So now I create an estimator, generic estimator. I specify this is my training script. This is my data set. I need to use. This is the compute target where it needs to run. And while it is running on the compute target, it needs to provision a Conda environment with all these dependencies is what I'm specifying here. And once I submit this run, basically it's going to, what it's going to do at the backend is it's going to track a run in Azure for me. It's going to create a Docker image with all these dependencies and with a source code, which is the train diabetes.py. It's going to deploy it to an image, and it's going to start running this experiment. And as it runs this experiment, it's going to log all the metrics I have logged and the output model, and it's going to place that in the for Azure tracking. So, and also you will also be able to monitor your runs locally as well. So, and you can see the data. You see the one of the clusters is started being utilized. And since because it's a single run, you see only one node is being utilized. When you do hyperparameter tuning and you specify a hyperparameter configuration, then basically it spins up a depending on the number of size of your cluster and the number of runs which you have configured to run parallelly, it runs each hyperparameter configurations on a different compute. So I'll show that. I'll quickly show you the outcomes of when it does a hyperparameter tuning. But basically, what it has done is now it is running this thing, and in the Azure portal, you will be able to see these runs being tracked, which you will be able to track this run in Azure portal. So it's going to finish this run right now. So all you see that it has basically deployed a model into that compute cluster, and I'm able to see that complete thing happening from my local notebook. So I am now going into the portal, and I'm going to just show you that run. So how these metrics are being logged. So the point I'm trying to want you to notice is that I'm tracking all the runs. I'm making all the metrics, all the outputs which are generated from that thing, and also the data which is being used. So if you see, I have the metrics which I logged, which is being available for me, and also the outputs, which basically has all the models which I have logged. So that's being available for me. So let me close the screen and go back. Okay. So, and also from the locally, you will be able to gather that metrics from that run. And once you can register that, go ahead and register that model. Once you are done, basically it will go ahead once you register this model, it will go ahead and version this model. And you also notice that I'm doing something like this while I register the model. I'm specifying a data set which I used for developing this model. So what happens at the backend is it's going to now version this, going to register the model in Azure Workspace, and is also going to track it that I used this version of the data set while I have created this model. So if you go and check in your workspace and you will and check your data set, you will be able to, so this is the data set we used. And if you go and check the models, you will see all the models which I registered with this version. So currently this is the current run which I made. And you also see a notification which has come. Basically, I will tell you how I have configured this, how the pipeline works. But basically you also have a notification that this new model has been registered. And it is registered against a particular version of the data set. And now that we have seen this, we'll also look at doing hyperparameter runs. So I'm not going to execute this run because it will do parallel runs. It might take time for us to do it, but I will show you the hyperparameter configuration when we do. All the steps, what I showed are same. In the estimator step, what we do is we have something called hyperdrive configuration, and we specify that I want to use a particular hyperparameter sampling method. There are many sampling methods like Bayesian, grid sampling, random sampling. I'm using Bayesian sampling here so that it optimizes based on the previous run, so that the hyperparameters converges to a proper value. So here, if you see that I have just doing a hyperparameter on the alpha parameter, and I'm asking the hyperdrive configuration to optimize around the mean squared value, and I'm asking it to minimize. So similarly, you can say accuracy and you can say maximize. So You can, and also you can specify how many runs you want to make, concurrent runs you want to make. And if you want to specify a banded policy, if you don't see an improvement in a particular hyperparameter across, say, multiple iterations you are doing on a deep learning model, if it's the validation loss is not reducing, then basically you can specify that don't continue on those runs. You can specify policies also on these hyperparameter models. So once you have this hyperparameter runs done, you will be able to see all those runs in Azure. Let me quickly show you those, how it's tracked. So this is a previously done hyperparameter run. So this hyperparameter run is all managed with something called as a hyperdrive, which is a framework as part of the Azure machine learning stack, which basically helps you. You do these hyperparameter runs in an unattended fashion. And once you have these runs, you will also see that of all these 4 runs which was done, the run number 10 is doing well because it has produced a low mean squared error. So if I go and see the run number 10, you will be able to see what alpha value was used for against this. And when you come back to the experiment in your notebook, and what you can do is you can get from your hyperparameter drive run, hyperdrive run, you will be able to get the best run and see this is the best alpha value. This is the alpha value against the best run, and I will be able to take that corresponding model and I register that particular model. So in this way, you will be able to run multiple hyperparameters, and you can against multiple hyperparameters, and you can choose the best model. Now let me get back to our deck and go into the next phase of MLOps. So once the data scientist does this, okay, uh, um, he has to combine all these steps in a pipeline way, so that this the pre-processing he did as a data scientist, the algorithm selection, hyperparameter tuning, model registration, all these can be made in a repeatable way. Right now I did it in a notebook you saw, but I want to make it as a repeatable pipeline, so that whenever there is a code change happen and somebody checks in a new version of model or some optimization did, I want to do this pipeline again, retrain the model, hyperparameter tune, and then register that thing. I want to make it as a reproducible step, so that even when a data drift happens, I can retrain my model. So that's basically is then when we go to the phase 1, which is basically you are going to reproduce the steps as a data scientist using a pipeline approach. So we have something called machine learning pipelines in Azure, which I'm going to quickly show you, which will help you do that. Right now you saw 2 steps. I did model training, hyperparameter tuning, as well as also registration of the model. So now if I want to do as a repeatable process using Azure machine learning pipelines, what I need to do. So that's what we are going to see right now. So machine learning pipelines helps you combine multiple machine learning steps. So the steps may be sequenced or run in parallel. So however you want, depending on your requirement. And each step can be run on different compute. So if you have data pre-processing steps, say if you want to do pre-processing in a Spark cluster, write it to Azure Blob Storage, and then in the next step you do the regular model development, and you want to pipeline this, then you can across different computes and across different data sets, that's possible. And output of one step can be pipelined to another step, so that's also possible. And also these pipelines can be deployed as REST endpoints, so that you will maybe able to rerun these pipelines as you require. And right now showing you a code-based approach. Also, pipelines can also be expressed as YAML files. So what we are going to see now in pipelines is, so these steps are all same steps. So I'm not going to repeat these steps for sake of time. I have initialized my workspace. I have taken my data set and the registered data set, what you saw. And I am attaching and compute resource for running my pipeline, which is the same compute which you saw now. And right now I'm going to have 2 scripts. I have separated it into different steps. One is the training step, which is having the best hyperparameter chosen already in there. And this training step is going to produce a model output, and this is written in a script file. And then I also have the second step, which is the register model step. Now, there is a small point I would want you to note. In the train step, if you see, I am writing the outputs to the current run's parent outputs folder. Because pipeline is a parent run, under this you will have step 1 run, step 2 run, which are all independent runs. And if you want to reuse resources, outputs from one run across another run, there are multiple ways to do it. One way is to write it on the outputs of the parent run, or you can write it into a data store and you pass it as a parameters from as inputs and outputs across steps. So there are two ways to do it. Right now I'm following the first approach. I'm writing it into the parent's outputs or output folder, so that the next step, which is the register model, can take the output which was generated from the train step and register that into the in the second step. So in the second step, I'm taking the parent's runs outputs and I'm registering that particular model into Azure, registering that model into the registry. So, and also again, I need for this entire thing to work, I need the dependency files expressed as conda files. And the different steps are here. I have two different steps. It's a Python script steps. Both are Python script steps. There are different kinds of steps are available. Databricks steps is available if you want to do a Spark based step. Data lake analytics steps are different kinds of steps are available depending on the compute you are going to use and the type of script you are going to perform. So I have two steps, train step and register step, and I'm specifying register should run after the train step because it has to be sequenced. And I'm creating a pipeline using this, and I'm going to validate this pipeline whether it is all fine. I have validated, and now I'm submitting a pipeline run. So what's happening right now is basically the same thing which has happened before, but I'm executing it as a pipeline. I can publish a pipeline so that I have a REST endpoint which is coming out, and I can also run a publish pipeline using a REST endpoint. So what I have done is I have made my pipeline repeatable, and so that I can call this pipeline whenever there is a code change or whenever there is a data drift. I can combine multiple steps and I can run this pipeline. So this pipeline is again going to register a version of the model. When you actually take it to production, you need to introduce an additional check, which I will show you later, like whether your current version of the model which you are going to register is performing, has a better metrics when compared to the model which was registered. So that's something which you will have to check before you keep releasing new versions of the model into production. So that we will see as when we see the DevOps pipeline, we will see that step as well. But right now, I think that you have got an understanding of what a build pipeline is. So where we execute multiple steps together so that we are able to publish a code which can develop and register a model, which is after doing all the steps of your pre-processing, one-hot encoding, normalization, hyperparameter tuning, and then it's going to register the right model. So having this pipeline in place right now, let's go and see how we are going to integrate it with DevOps. So right now, if you see my pipeline is running, let me just quickly show you that. So if you go into pipelines, you see that there is a pipeline which is running right now. So which will basically train the model on that compute, and it will register that model into the registry if it is once. So the first step is done. Now it's running this step of registering this model. So now since we have this understanding, let's go and talk about integration with DevOps. So Azure Machine Learning Service has been integrated with DevOps, and you have a separate module with Azure DevOps now, which is for machine learning. So once you have that module installed as part of your Azure DevOps, you will be able to integrate your build and release pipelines with Azure Machine Learning. And so as part of this build pipeline, what we have is we have two phases. The first phase is, say you have the basic experimentation done and you have a basic version of working code available and you have checked into your GitHub repository or whatever repository you have, and you start doing the start doing your initial code quality unit tests, which is run on the code. And then once those tests are run, you basically build that pieces of code, whatever I showed as a pipeline, and then you publish that machine learning pipeline. Then the model will get published and it is going to have an endpoint. And what that published pipeline is doing is it's training, evaluating, and registering the model. So, and at the backend, I have just put two scripts which will do that. The build train pipeline.py is the script which will build the machine learning pipeline, which is basically the same code which I showed you right now in the notebook, which is going to build your model, and it is going to publish your pipeline as an endpoint. And then there is a next step which is running the training pipeline, so that the model gets trained and it gets registered. The second step is the execution. The first step is the actual build, and after basic code quality checks. And in Azure DevOps, all the pipelines, the Azure DevOps pipelines are different from the machine learning pipelines. The Azure DevOps pipelines is the one which is basically going to help us run this build train pipeline.py to publish that model into Azure Machine Learning. The DevOps pipeline also is expressed in can also be expressed in YAML files. So if you go, if you see, I have specified two YAML files: the base pipeline YAML and the build YAML. So the base pipeline YAML will do the basic code quality checks, like whatever you want to do across. If you want to reuse this base code quality check code across different repositories, you can use a base pipeline, and you can extend that training pipeline from this base pipeline. So the base pipeline just does just some linting and unit tests, and second comes the actual train pipeline, which we saw right now in the notebook. And that same code has been expressed as Python scripts and being called from the YAML file. And given that background, so build pipeline usually in Azure DevOps has executes in multiple stages. So in stage one, we do the model CI pipeline, which is basically nothing but which is building your Azure machine learning code and publishing it as a REST endpoint. That's what model CI does. Then second stage is the trigger AML pipeline, which will call that what was published by the build train pipeline, and which actually does the training and then register the model into the registry. So whenever a code change, this build pipeline is executed so that all your basic code quality checks are done, tested, and you build and publish the pipeline based on the updated code, and then you run the updated code to produce a new version of the model. Check if that model is doing better than the current version deployed, and then you deploy that. So let's have a quick demo of the Azure DevOps build pipeline. So let's me go into the Azure DevOps Workspace. So in Azure DevOps Workspace, the first thing you do is you go and specify that you want an integration with Azure Machine Learning. So you go and once you have that module installed with you, the MLOps module, then you can go and specify a service connection to connect to your Azure Machine Learning repository, so that you have an integration with this Azure Machine Learning already established. Once you do this, you also go and specify a few variables which you will use as part of your pipelines, expressed in the library section of it, where you have something called as a variable groups, which are like environment variables, which will be used. For example, we will use which cluster we want to run the model, or if you want to provision a cluster, then you need to specify what kind of cluster you need. Do you need to auto trigger training after every code change? So those kinds of variables, if you want to control things, then you can specify it here. What name you want to give to the machine learning experiment which you're going to run, which location is your workspace. So all that, if you want to control it from an environment perspective, you can control it. So you give a model name, the scripts which has to be executed for training and registering your models, the service principal, app ID, and secret, which is required for Azure MLOps to contact your Azure Machine Learning Workspace. So all this is required basically to give a more parameterized pipeline so that you can control a lot of options as you run your pipelines. So now we are talking about the build pipeline, right? So the build pipeline, which is having 2 steps. So let's go and look at how you establish those pipelines. So this is my build pipeline, which basically gets triggered whenever there is a code change, right? So whenever I trigger a code change, so a build pipeline is triggered, which calls 2 steps. The model CI step, which is basically building the machine learning pipeline and publishing it to produce an endpoint. Second step is the one which is actually running the pipeline. So now how to develop these pipelines is, as I said, you will need some YAML files to be written, which is very easy to express these YAML files. As I said, we have 2 YAML files. One is for the build train, and another one is the base pipeline, where you can do a lot of linting checks against your code. Say, for example, if you want to call here the Flake package is being used, PyTest is used for unit tests. So if you want to run this first against your source code, and then in the actual, this is the actual build pipeline, which is executing, which is creating and publishing the machine learning model, and then second step, it's executing the machine learning pipeline. So if you see in the model CI, there are 2 stages. The model CI stage, I call the build train script, which I have specified in the environment variable, which will build the machine learning pipeline and publish it. And second step is the actual trigger AML pipeline, which is the second stage, which is calling the invoke model pipeline job, and it is in turn calling the run train pipeline script. So these are the scripts. These scripts are nothing but the same scripts which we wrote in the notebook. So I'll quickly show you that. In your code, you have something called as ML service. Under ML service, you can see the build train pipeline. This is nothing but the same step which we saw in the notebooks, which is having the AML compute expressed. We use pipeline parameters in addition because we want to control which release is generating what version of the model. We want to track that. So we pass some parameters like model name and release ID from the variable group which I was showing you. And also, so the rest of the steps are same. If you see the train step, the evaluate step, which was going to evaluate and see if the current performance is better than the already existing model's MSE values, and then it is going to publish only if it is better. So these are the 2 steps which are being invoked. If you wonder how does it know what MSE value was there in the older model, so what it does is it takes the registered model and the corresponding run, which is there in the experimentation tracking I showed you, and it takes the run object and then takes the metrics which was logged against that, so that we will know what was the run, what is the MSE value which is in the current production model. So in that way, we will be able to, whatever we are deploying will be definitely better than what we had before. So so let's do a small code change just to show you. Basically, which triggers this pipeline. So let's do a commit. So now this is going to trigger this build pipeline because I have made a code change and the pipeline is configured to run. And if you go to the pipelines, it basically triggers a build pipeline. And this build pipeline will basically now have 2 steps being executed. The 2 steps, one is it's going to publish a new pipeline because I have changed my code. And once it publishes, I am going to take the new endpoint and it's going to register the model. If the model is better from the updated version of code, then it goes to and register the model. This is on the build part. As the pipeline gets executed, because we are running out of time and have quite an amount of topics to cover, let's go into and see. As the pipeline keeps running, let's go and see how we operationalize our model also. So when it comes to the operationalization of the model, now we have a model registered in the registry. So when we operationalize it, what all we need? We need the registered model, which is some serialization format you have. It may be a folder in case of your deep learning models, or it can be a simple pickle file. The second thing, what you need is what are the dependencies which are required to run that model. So that also needs to be tracked, right? So which is your Conda dependency files. Third thing is you need a compute when you want to deploy your model. You need a compute to run that model on. Depending on if it is a batch mode, you might run it on some compute. If it is inferencing, high performance inferencing requirement, then you will run it on a Kubernetes cluster with multiple pods up with your deployment. So that's one way to look at it. And another thing is like whether you have to profile and see whether your model performance is right on that particular compute. So you need to do some CPU memory profiling also when you deploy your models. So all this is possible because it has been kind of built with Azure machine learning. So as I said, we will, to deploy a model, you need a registered model. You will need a deployment compute, which can be for a QA deployments. You might just go with single container instance. If it's a prod deployment, you might go for a Kubernetes cluster. You will go for a Kubernetes cluster. You will also need an inference configuration file, which is the environment which you need to have for running your model, which is basically your YAML files, which is having all your dependencies expressed. And also, now how is it going to run in a production environment? We are going to bundle all these dependencies. We are going to create a Docker image, and that Docker image is going to run on the cluster. So where to find that? So when the model is deployed, how to load the model, from which location I should load the model, and how should I score it against the input data, and I give the response back to the user. All this is expressed in a scoring file. So from our end as a developer, we write only the scoring file, and we tell that these are the dependencies we want to make. Rest of everything is taken care by Azure. So I will quickly show you a deployment pipeline also. And once we have the deployment pipeline, then basically our model is able to run in a scalable way in a deployment environment. So let me quickly show you what is involved in deployment. So let's go back to the notebook. So I'll quickly show you the things which I just told you. So we are going to see how we are going to deploy a web service to Azure Kubernetes cluster. So these steps are all same. So we have a workspace. We have workspace configuration, so that we are registering the model deploying the model in the right workspace. We already registered the model, so we are not going to we need an environment for that model. So we will have to have the Conda file created. That we will need to do. This is the important part apart from the Conda file, which is the scoring file which I spoke about. This is the scoring file. Is going to have two methods, which was basically the init and the run method, which will initialize your model, loading it from the right location from your container image. So this location is the location which you gave when you registered the model. So when you registered the model, you gave a particular location from where to look for that model file. So that same path is loaded in the init method, and then the run method loads the input data and it predicts on that input data. So it's a very simple file. You write a simple scoring file. The inference config is very important, which is a combination of that scoring file and the environment which you want to run. And the other thing what we need is, apart from the dependency files, we will need to provision the compute which we need to deploy the model, right? So you provision a cluster. If you have an existing cluster, you can attach that cluster. And all you need to, next step is just deployment, where you specify this is the workspace I need to deploy. This is my web service name. This is the model you should use. This is the dependency files, which is the scoring files and the Conda dependency files. And then you have the deployment target. So once your model is deployed, basically you will have the model running as a web service, and you will be able to score the model against that web service. It has an endpoint. So let me quickly show you. Let's do a deployment right now. And let me show you how this is integrating with DevOps also, Azure DevOps also. So given that pipeline has run successfully, let's go and quickly check that if it has finished running. Yeah. So you should see right now this pipeline has run from Azure DevOps. So if you go and see in your Azure Machine Learning Workspace, you will see that pipeline would have registered a new version of the model. So let's see this. Yeah, this is the version 6, which is the new version of the registered model. And so once the model is registered here, it should have automatically also kicked off the release pipeline. So let's also check that if the release pipeline is running or it has already run. So once a model is registered, I have defined a release pipeline on an event. The model is registered, a release pipeline. So right now, register the model, and we should see that this pipeline will kickstart. So let it kick. Meanwhile, let's see what has gone into defining pipeline. So let's go and edit this and see how we configure a release pipeline. So till now we have seen how to till the step of registering the model. So we can define something called as a release pipeline. Once you have gone to that step, you select that artifact. That this is the artifact name which will be there in the registry. And if you see a new version of this coming up, you enable a trigger. That enabling this trigger will create a new release every time a new model is registered. So when a new model is registered, I create a trigger, and that trigger is going to create a deployment activity into the Azure container instance. What this Azure container instance activity task is going to do is, it's going to deploy the newly registered model. It's going to check in my workspace. I have configured that. And it is also going to, we are also going to specify the inference config file which we need to use, which is having that scoring file as well as the YML file, which is having the dependencies which are there. So once you specify that, then also you specify the deployment information, which is that deployment configuration, which is having how many CPUs and how much of memory I need to provision for the Kubernetes cluster or the container instance. And you also specify the instance name you want to create. And if there is an existing deployment, you override that deployment. You can specify this. And also you can put controls that if you need approvals on every phase, you can put, so that before it kicks off this pipeline, it will go for approvals, then you approve it, and then it goes for the deployment. And once this deployment is done, and also there is a checkbox, you see something called as a validate and profile, right? What this does is basically when your model is deployed, it will see whether what is the consumption of memory and the CPU profiles. So those will get generated so that you will know whether you have a right compute environment for running your models at a scale what you need. So once this is done, you also have, once this task is complete, you can also have a task of deploying it into a production AKS deployment is done. So right now you see I got an automated notification that my model has been registered. So once the model is registered, I should see this pipeline kick off because I have enabled this trigger. So let's go and see if this release pipeline is triggered right now, which will, yeah, you see that now this has been triggered. So basically it's going to deploy the version of the model into the Azure container instance for my QA and into the production into AKS. So this pipeline task is running right now. So in this way, we can automate this complete pipeline. Now let this keep running. Let's go back and see, talk about a little bit on the data drift. So we saw this release pipeline part. So let's skip this slide. We saw the AKS ACI deployment, which is being triggered after the model registration. So we have seen this demo. Let's talk a little bit about data drift. So Azure offers monitoring data drifts, which basically means once your model is deployed, say your data keeps changing. So, and your model will become it's not performing well on the data. So you need to handle that. So there should be a way which will detect a data drift has happened, and it should notify you. And upon notification, you should be able to retrain your model or take an action. So that's what there. So there is a provision to do data drifts with Azure with the help of data sets. So what you need to do is for data drift, you need to have you have to register a baseline data set. So in terms of models, your baseline data set will be your training data set itself. So that's what you will register. And also you should have a mechanism to keep collecting the data, the new data which is coming for scoring, so that you will need to monitor that for data drift. So we need to take care of those two aspects. So let's see how basically data drift works with the help of a sample data set, and then I can quickly show you how you can do it in terms of your production models also. So for data drift, so let me quickly go to this notebook and show you how you register a data for a. So I'm going to use a weather data set, which is having, because I have the data collected across different. So this is from the Azure Open Datasets, which is available. Different datasets are available in Azure Open Datasets. So this dataset is taken from there, and this dataset, if you see, it's been registered 2 times. One, you see it is registered as a target with a target name where all the files has been registered as a target. Then you see something I have registered something called as a baseline. So baseline is like your training data against which you want to measure the drift. Say January 2019 data has been registered as the baseline. After that, all the 12 months data has come. So AKS deployment has been done. We have got the notification. So the deployment has been successful. So once this deployment is done, so you are going to monitor the data. So for that, we will register a baseline, and then we keep track of the every time when a new data is gathered, depending on the frequency we configure, based on every day or every month you want to do the monitoring, run this data drifts, then you have to configure that. So right now, since I have configured my baseline data as 2019 January data, data drift has to run on a compute, right? Because that is also a computation. So we have to have a compute target created, and you create a data drift monitor, which will, once the monitor is created, you call it as a weather monitor. You specify which compute target it is going to run, what frequency it has to run, what features you should consider. If you give none, basically it considers all the features in the data set. Then you can specify a drift threshold. It's a threshold from 0 to 1. So beyond certain value, if you want to alert, you can specify, otherwise it will use the data default threshold. Latency is, since it runs on a periodic basis, if you want to wait for some hours before your data arrives, so every week it runs, but it should start only after so many hours, then you can specify that latency. And if a data drift is noticed, then who should I contact upon a data drift? Or what should I do, basically? So it will trigger an alert, and then you can capture that alert and you can automate the retraining pipeline. So I will show you that in the next step. There could be certain features you don't want to involve in your data drift, because certain columns in your data might drift, right? For example, year, day, and all version will keep changing. So you don't want to include that data in your data drift. You can specify that. And also, if you have some historical data and you want to perform a data drift on your historical data, that is also possible. So you do a backfill run. So, or you can enable a pipeline schedule. Pipeline schedule is running on every data, on the data which arrives. So let's quickly do a backfill run, just to quickly show you the alerts. So let's go back to the portal. I will show you what data drifts generate. So under the data sets, you have data set monitors, something called as a data set monitor. Since from the code I registered a weather monitor, which you saw, I have that monitor available. And you see that I gave the baseline data set as January data set, and after that some 10 months of data had come. So I can do a data drift analysis from January. So when you do that, you will see how the data has been drifted. Say this is your baseline code, and how the data from March, April has drifted. I have run it from April. So how it has started drifting in terms of percentage, which is the drift magnitude from which it has drifted, and what features have contributed to the drift. say here you see the temperature feature has been responsible for much of the drift, and depending if it is a categorical features or if it is a numerical feature, you have different distance metrics. So for a numeric feature, you have a sustained distance, which is calculated based from the probability distribution of how the data has deviated from the initial baseline version, which is your training data set. So once you monitor, you are able to see this drift. You can also, I have also configured an alert. Okay, so when the drift coefficient is beyond some extent, then it will trigger an alert for me. So once the alert is triggered, how can I retrain it? So there is an option there as well. So what is done is Azure Machine Learning is integrated also with event hubs and logic apps. So whenever an event is triggered, you will be able to specify basically that event can be captured, and you can establish a pipeline. Say if you logic app pipeline, say I have set up a logic app pipeline which captures the events from the Azure Machine Learning Workspace. And whenever a model is registered or deployed or a data drift is detected, it sends an email. And also, even if I want to queue a new build, say if a data drift is detected, Logic App is also integrated with Azure DevOps as well. So it has, now I'm asking it to use the build train pipeline, which I triggered, right? Whenever there is a code change also, I'm able to trigger. And similarly, whenever there is a data drift also, I'm able to capture that data drift, and I'm able to trigger that thing. So if you see right now, there is an event data drift notification. So my data drift has happened. So if this pipeline is active, it is going to call this. I have not yet published this. If you can publish this. Right now I have published only the email part. So it is sending an email. If I publish this thing, then it is going to queue a new build, and it's going to cause a release again. So in this way, data drifts or code changes can automatically trigger your build and release pipelines also. So the overall architecture, if you have to see, basically, it looks like this. So I didn't talk much about Data Factory, but Data Factory comes into place where you have a very heavy data pre-processing involved, where you have multiple sources of data and you want to pipeline that. Then you bring in Data Factory to orchestrate that flow. And all of these are integrated. The Data Factory is also integrated with Azure DevOps. So you can also, once your data drift is detected, you can, from logic apps, you can call Azure Data Factory, run your pre-processing, and when after that step is complete, you can again trigger your DevOps pipeline, your build and your release pipeline. So overall, it basically looks like this. So once your data scientist is done with your initial experimentation level 0 runs, he basically checks in the code. And once he checks in the code and he keeps making changes, that basically involves a pipeline of code quality checks, unit tests done. A robust machine learning pipeline is built. The pipeline is published. Build pipeline is published as a REST endpoint. Then the pipeline is called to register a model. And once the model is registered, you then have a new version of the model, which will trigger a release. You can have your approval gates as required. Then that release is going to be on QA and then go into prod. And then when it has gone into prod, you can also monitor your data sets for data drift. And then you can, once the data drift, from the data drift, you can when a data drift is detected, you can call retrain pipeline again, and or you can call data pre-processing pipeline before you call your retrain pipeline. So this is the whole work of how this is done. So given that we are towards the closure time, I just wanted to quickly show you when you are using data drift, you need to take care of some couple of steps when you register your model in AKS. When you register your model and create a web service. So I'm just showing you that part. See, because you are doing a data drift monitoring, all your scoring data has to be captured, right? So only then you will be able to measure a data drift. And also you have to to register your training data as your baseline. So these two steps has to be taken care. So how do we take care of those steps is what I will just quickly show you. So when you deploy a model, you say that collect model data equal to true, and also you also update your scoring script also accordingly to collect the data. When you do this, your new scoring data will get collected in the Azure Blob Storage. So that's taken care. So your new data is now getting stored in the Azure Blob Storage, which you can use. And once your data is there, and also you also need to also configure your model training data as the baseline, right? So how you configure that is when you register your model, you say that against the data set against which this model was created, so that you have the baseline, you have a tracking of that. And once that is done, you will be able to configure your data drift monitor, the data drift, actual data drift monitor against that web service and against that model version. And you can say how frequently it should monitor and which compute target the data drift run should run. And in this way, this whole pipeline of building your models is possible, and kind of you can maintain robust pipelines, build and release pipelines in your production. So before I go on for Q&A, I just want to point out to few resources which is available. So you have a separate MLOps Python repository, which is the repository which I run through right now with you. So this is what I went through with you right now. This is more of a Python-based repository. We also have command line REST-based calls also, if you are more comfortable using those approaches. So that's there in your MLOps. So we have a data drift monitor run, which is coming. So this is the data drift monitor run, which was triggered. So once you, yeah. So, and also we have a lot of sample notebooks to help you get started with Azure Machine Learning. And also we have a detailed good Azure Machine Learning documentation, which can help you go through this. So that's all I had for the session, and thanks for patiently listening. And I'm open for Q&A now.
Yeah, thank you, Mercy. Before we take Q&A, I just have a couple of slides.
Okay, sure.
Yeah, hope it's a wonderful webinar. Meanwhile, you can put up your questions in Q&A panel. Beyond this webinar, you still have questions, then you can join these groups and post your questions. We'll get that questions over to Mercy and then get that answered. So if you have any questions, this is your time to please put up your questions here in Q&A panel. And SQLMaestros is coming up with video courses on SQL Server performance tuning and T-SQL querying and programming. Video courses are based upon master classes and master series, which will have 100+ hours of content, which is a comprehensive coverage of SQL Server internals, troubleshooting and performance tuning, query tuning, and T-SQL querying and programming. So the best advantage of subscribing to video courses are you can watch anytime, anywhere, and as many times as you can. So if you want to learn more about these video courses, you can visit SQLMaestros.com, or else you can simply drop an email to contact@SQLMaestros.com. SQLMaestros also offer a self-paced learning solution called Hands-on Labs, where you will be provided with a lab document. If you go through the document, you'll have a script supporting explanations, observations, and screenshots, so that at the end of the document, you will be able to become an expert in that particular topic. So there are more than 120+ labs on SQL Server, Azure, Power BI Analytics, and Cosmos DB, etc. And there are close to 2,000 subscribers also. So if you wish to learn more about Hands-on Labs project, you can visit SQLMaestros.com, or else this particular bit.ly link, or else you can simply drop an email to contact@SQLMaestros.com. So there are so many webinars lined up in the month of November and December. Here is the list of upcoming webinars. You can all the webinars and in-person events are free for community. There are this particular event is finished, but all the webinars are lined up. So you can see a lot of comprehensive coverage or entire Azure data platform and AI stack. So just visit DataPlatformGeeks.com and you can able to register for all the events. So with this, I'll conclude. Please, over to Mercy to take our questions.
So I have answered a couple of questions already. One was around whether you can use ADF and you can call an Azure machine learning pipeline. So the answer is yes. So the reason being, machine learning pipelines are REST endpoints. You can call REST endpoints from ADF, and also even you can directly also call Azure machine learning model endpoints, which are the Kubernetes services, web service which is serving your model. So that is also anyway a REST endpoint, so which also can be called. In addition, Logic App also provides integration with ADF. So if you have an ADF pipeline published, and whenever there is a data drift, you want to first call ADF before calling MLOps DevOps pipeline, then you can first call ADF pipeline to prepare your data and then have your data prepped up in storage, and then you can also basically after that your data is prepped up, then you can call your DevOps pipeline for build and release. So yet another question was on the GitHub integration is used for model versioning. Yeah, we can we can use that, and also when multiple users are being using your models and you have a lot of reviews in place, then you can bring in the pull request process also for reviews, and then you can once post that review and gate approvals are done, only then if you want to kick off your pipe, it's not that check-in will always trigger a pipeline. You can have a lot of conditions, tags defined, which basically should trigger the process. So that's possible. And also, can we do feature engineering for ML project in Azure? Yes, there are a lot of feature engineering which is available as a module called model explainability, which also helps you see when you're building your machine learning models what features are contributing towards your accuracy. So you can there is an explainable module, which is explainability module, which you can make use of while you are doing feature engineering on your project, which for yielding best results. And also with automated machine learning, it automatically does feature engineering for you. It has different feature engineering mechanisms. It understands which features are contributing, which are not contributing itself. So if there is a lot of variance in your features, it automatically drops features. And it also does data pre-processing, certain data pre-processing and feature generations as well. For example, time features are generated. If it is a text-based models, it generates your n-gram features are generated automatically. So there are two modes. One is AutoML generates its features of its own and also gives you model explainability on those generated features. Or if you are generating your own, you are iterating your own ways for feature engineering, then basically you can use the explainability package to get that explained. Cheat sheet for different computes. We have suggestions on what computes are good for which scenarios, so that I can share it. Yes. So for example, there are various GPU configurations which are available, and also there are configurations which are available which are for memory intensive projects, compute intensive projects. So I can share you that list. Yes. So we do have a cheat sheet.
Looks like there are no more questions. So if you still have any questions, you can use our social channels to post your questions. And we had put up a thank you note to Mercy in our LinkedIn channel. The LinkedIn link is available in chat window. Please post your feedback and comments there, so that will encourage our speakers to come back and deliver free sessions for you. So the link is again available in chat window. That is the LinkedIn link. So please post up your questions also you can ask there. Please put up your comments and feedback there in the LinkedIn link. So if you still have any questions, you can use our social channels to ask your questions. So with this, we can conclude this webinar. Thank you very much, Mercy, for your wonderful time and your time. You are spending your time in your busy schedule with the community. Thank you.
Yeah. Thank you everyone for listening. Yeah.